didn't do any research as an undergrad, and so I thought, oh, I'm going to do 2 years for masters and then get a job in industry and be happy, make a lot of money. And when I realized what research was all about, I was really so excited about this that I said, oh, I'm not going to do a master's, I'm going to get a PhD, and I have made this my career now. My name is Boland. I'm a professor here at UTEC. I'm also directing the biomedical engineering programs. Basically, a lot of students in my lab, graduate students, are doing research on artificial organs. So we use, sometimes we use printers to print layers of tissues. Sometimes we just grow them from maybe stem cells. But the point is that they are growing these artificial organs in the dish. The purpose for this is to actually eventually implant this in a human being. That means an organ transplant, but there's a shortage of organ transplants, as you all know. Right? At kidneys, for example. 10 years ago, you had a higher chance of getting a kidney than now, because the list of people waiting for an organ for a kidney gets longer and longer and longer, because we just don't have enough donors. So something has to be done, and we think. Me and many of my colleagues think that engineering, biomedical engineering, could potentially provide a solution. So one intermediate step is, before we can find out if this is working in humans, we'll have to test it on animals. So the RDC is really designed to do this. So the students will work with the grad students to get these artificial organs or organoids, and they will then in the RDC learn how to do surgery and implant these organs or organoids into an animal, into a mouse. So I think it's very well rounded, especially you get the practice in the lab. I mean, some students are very smart maybe and read a lot and know a lot, but maybe lacking lab skills. So this will provide every student with the skills, lab skills and the theoretical foundation. Then back in the lab, they will have to do the staining of the tissues. They have to slice them into 5-micron thin slices, so they will learn how to do this. They will learn how to do the microscopy and how to analyze these tissues and find out what these features are. So they develop a whole skill set that I think is very, very useful for their future work in graduate school or even medical school. They can see, oh, all right, this is what the grad students do, this is how they work in the lab, how much fun they have. In fact, they do have a lot of fun in our labs. So I think that can be contagious. Everybody who is interested in biomedical engineering are invited to come and spend some time with us, and especially in the RDC.